Sexual selection is a mode of natural selection where typically members of one biological sex choose mates of the other sex with whom to mate. These two forms of selection mean that some individuals have better reproductive success than others within a population, either from being more attractive or preferring more attractive partners to produce offspring. For instance, in the breeding season, sexual selection in frogs occurs with the males first gathering at the water's edge and make their mating calls, croaking. The females then arrive and choose the males with the deepest croaks and best territories. Generalizing, males benefit from frequent mating and monopolizing access to a group of fertile females. Females have a limited number of offspring they can have, and they maximize the return on the energy they invest in reproduction. First articulated by Charles Darwin, who described it as driving speciation, and that many organisms had evolved features whose function was deleterious to their individual survival, and then developed by Ronald Fisher in the early 20th century. Sexual selection can lead typically males to extreme efforts to demonstrate their fitness to be chosen by females, producing secondary sexual characteristics, such as ornate bird tails like the peacock plumage, or the antlers of deer, or the manes of lions, caused by a positive feedback mechanism known as a Fisherian runaway, where the passing on of the desire for a trait in one sex is as important as having the trait in the other sex in producing the runaway effect. Although the sexy son hypothesis indicates that females would prefer male sons, Fish's principle explains why the sex ratio is 1-to-1 almost without exception. Sexual selection is also found in plants and fungi. The maintenance of sexual reproduction in a highly competitive world has long been one of the major mysteries of biology, given that asexual reproduction can reproduce much more quickly, as 50% of offspring are not males, unable to produce offspring themselves. However, research published in 2015 indicates that sexual selection can explain the persistence of sexual reproduction in organisms. Sexual selection in birds, mammals, humans, scaled reptiles, amphibians, insects, spiders, major histocompatibility complex. Sexual selection has been observed to occur in plants, animals and fungi. In certain hermaphroditic snail and slug species of mollusks, the throwing of love darts is a form of sexual selection. Certain male insects of the Lepidoptera order of insects cement the vaginal pores of their females. Today, biologists say that certain evolutionary traits can be explained by intraspecific competition between members of the same species, distinguishing between competition before or after sexual intercourse. Before copulation, intrasexual selection, usually between males, may take the form of male-to-male combat. Also, intersexual selection, or mate choice, occurs when females choose between male mates. Traits selected by male combat are called secondary sexual characteristics, which Darwin described as weapons, while traits selected by mate choice are called ornaments. Due to their sometimes greatly exaggerated nature, secondary sexual characteristics can prove to be a hindrance to an animal, thereby lowering its chances of survival. For example, the large antlers of a moose are bulky and heavy and slow the creature's flight from predators. They also can become entangled in low-hanging tree branches and shrubs, and undoubtedly have led to the demise of many individuals. Bright colorations and showy ornamentations, such as those seen in many male birds, in addition to capturing the eyes of females, also attract the attention of predators. Some of these traits also represent energetically costly investments for the animals that bear them. Because traits held to be due to sexual selection often conflict with the survival fitness of the individual, the question then arises as to why, in nature, in which survival of the fittest is considered the rule of thumb, such apparent liabilities are allowed to persist. However, one must also consider that intersexual selection can occur with an emphasis on resources that one sex possesses rather than morphological and physiological differences. For example, males of Euglossa imperialis, a non-social bee species, form aggregations of territories considered to be leks, to defend fragrant-rich primary territories. The purpose of these aggregations is only facultative, since the more suitable fragrant-rich sites there are, the more habitable territories there are to inhabit, giving females of this species a large selection of males with whom to potentially mate. More recently, interest has arisen in cryptic female choice, a phenomenon of internally fertilized animals such as mammals and birds, where a female will get rid of a male's sperm without his knowledge. Finally, sexual conflict is said to occur between breeding partners, sometimes leading to an evolutionary arms race between males and females. Sexual selection can also occur as a product of pheromone release, such as with the stingless bee, Trigona corvina. Female mating preferences are widely recognized as being responsible for the rapid and divergent evolution of male secondary sexual traits. Females of many animal species prefer to mate with males with external ornaments, exaggerated features of morphology such as elaborate sex organs. These preferences may arise when an arbitrary female preference for some aspect of male morphology, initially, perhaps, a result of genetic drift, creates, in due course, selection for males with the appropriate ornament. One interpretation of this is known as the sexy son hypothesis. Alternatively, genes that enable males to develop impressive ornaments or fighting ability may simply show off greater disease resistance or a more efficient metabolism, features that also benefit females. This idea is known as the good genes hypothesis. In humans, Darwin conjectured that heritable traits such as beards and hairlessness, significant in the geographical differentiation of human appearance, are results of sexual selection. Geoffrey Miller has hypothesized that many human behaviors not clearly tied to survival benefits, such as humor, music, visual art, verbal creativity, and some forms of altruism, are courtship adaptations that have been favored through sexual selection. In that view, many human artifacts could be considered subject to sexual selection as part of the extended phenotype. For instance, clothing that enhances sexually selected traits. Some argue that the evolution of human intelligence is a sexually selected trait, as it would not confer enough fitness in itself relative to its high maintenance costs. Darwin and the development of the theory. The theory was first proposed by Charles Darwin in The Origin of Species and developed in The Descent of Man and Selection in relation to sex, because Darwin felt that natural selection alone was unable to account for certain types of non-survival adaptations. He once wrote to a colleague that, "The sight of a feather in a peacock's tail, whenever I gaze at it, makes me sick." His work divided sexual selection into male-male competition and female choice. Depends, not on a struggle for existence, but on a struggle between the males for possession of the females. The result is not death to the unsuccessful competitor, but few or no offspring. When the males and females of any animal have the same general habits, but differ in structure, color, or ornament, such differences have been mainly caused by sexual selection. These views were opposed by Alfred Russel Wallace, though much of his opposition took place after Darwin's death. He argued that male-male competitions were forms of natural selection, but that the drab peahen's coloration is itself adaptive, as camouflage, and that ascribing mate choice to females was, in his opinion, attributing the ability to judge standards of beauty to animals far too cognitively undeveloped to be capable of aesthetic feeling. Wallace also argued that Darwin too much favored the bright colors of the male peacock as adaptive without realizing that the drab peahen's coloration is itself adaptive, as camouflage. Ronald Fisher. Ronald Fisher, the English statistician and evolutionary biologist, developed a number of ideas about sexual selection in his 1930 book The Genetical Theory of Natural Selection, including the sexy son hypothesis and Fisher's principle. The Fisherian runaway describes how sexual selection accelerates the preference for a specific ornament, causing the preferred trait and female preference for it to increase together in a positive feedback runaway cycle. In a remark that was not widely understood for another 50 years, he said, "Plumage development in the male, and sexual preference for such developments in the female, must thus advance together, and so long as the process is unchecked by severe counter-selection, will advance with ever-increasing speed. In the total absence of such checks, it is easy to see that the speed of development will be proportional to the development already attained, which will therefore increase with time exponentially, or in geometric progression." Ronald Fisher, 1930. This causes a dramatic increase in both the male's conspicuous feature and in female preference for it, until practical physical constraints halt further exaggeration. A positive feedback loop is created, producing extravagant physical structures in the non-limiting sex. A classic example of female choice and potential runaway selection is the long-tailed widow bird. While males have long tails that are selected for by female choice, female tastes in tail length are still more extreme, with females being attracted to tails longer than those that naturally occur. Fisher understood that female preference for long tails may be passed on genetically, in conjunction with genes for the long tail itself. Long-tailed widowbird offspring of both sexes will inherit both sets of genes, with females expressing their genetic preference for long tails, and males showing off the coveted long tail itself. Richard Dawkins presents a non-mathematical explanation of the runaway sexual selection process in his book The Blind Watchmaker. Females who prefer long-tailed males tend to have mothers that chose long-tailed fathers. As a result, they carry both sets of genes in their bodies. That is, genes for long tails and for preferring long tails become linked. The taste for long tails and tail length itself may therefore become correlated, tending to increase together. The more tails lengthen, the more long tails are desired. Any slight initial imbalance between taste and tails may set off an explosion in tail lengths. Fisher corresponded that the exponential element, which is the kernel of the thing, arises from the rate of change in hen taste being proportional to the absolute average degree of taste. Ronald Fisher, 1932. The female widow bird will desire to mate with the most attractive long-tailed male so that her progeny, if male, will themselves be attractive to females of the next generation, thereby fathering many offspring who will carry the female's genes. Since the rate of change in preference is proportional to the average taste amongst females, and as females desire to secure the services of the most sexually attractive males, an additive effect is created that, if unchecked, can yield exponential increases in a given taste and in the corresponding desired sexual attribute. It is important to notice that the conditions of relative stability brought about by these or other means will be far longer duration than the process in which the ornaments are evolved. In most existing species, the runaway process must have been already checked, and we should expect that the more extraordinary developments of sexual plumage are not due, like most characters, to a long and even course of evolutionary progress, but to sudden spurt of change. Ronald Fisher, 1930. Since Fisher's initial conceptual model of the runaway process, Russell Land and Peter O'Donnell have provided detailed mathematical proofs that define the circumstances under which runaway sexual selection can take place. Reproductive success. The reproductive success of an organism is measured by the number of offspring left behind, and the quality or probable fitness The grossest blunder in sexual preference, which we can conceive of in animal making, would be to mate with a species different from its own, and with which hybrids are either infertile, or, through the mixture of instincts and other attributes appropriate to different courses of life, at so serious a disadvantage as to leave no descendants. It is no conjecture that a discriminative mechanism exists, variations in which will be capable of giving rise to a similar discrimination within its own species, should such a discrimination become at any time advantageous. Ronald Fisher, 1930. Individuals in each region most readily attracted to, or excited by, mates of the type they're favored, in contrast to possible mates of the opposite type, will, in fact, be the better represented in future generations, and both the discrimination and the preference will thereby be enhanced. It appears certainly possible that an evolution of sexual preference due to this cause would establish an effective isolation between two differentiated parts of a species, even when geographical and other factors were least favorable to such separation. Ronald Fisher, 1930. Sexual preference creates a tendency towards assortative mating or homogamy. The general conditions of sexual discrimination appear to be the acceptance of one mate precludes the effective acceptance of alternative mates, and the rejection of an offer will be followed by other offers, either certainly, or at such high chance that the risk of non-occurrence will be smaller than the chance advantage to be gained by selecting a mate. The conditions determining which sex becomes the more limited resource in intersexual selection can be best understood by way of Bateman's principle, which states that the sex which invests the most in producing offspring becomes a limiting resource over which the other sex will compete, illustrated by the greater nutritional investment of an egg in a zygote, and the limited capacity of females to reproduce. For example, in humans a woman can only give birth every 10 months, whereas in theory a male can become a father every day.